Hello, this is awesome. All right, so I am the head of product at Eppo. Eppo is a data warehouse native, A/B testing, and feature management platform. Think about the experimentation tools that a Netflix or Airbnb has. That's what we give to our customers. And I myself have led experimentation practices. So from that to now working with hundreds of experimentation practitioners, I have seen companies big and small run into problems with experimenting. And today, we're going to talk about what we're getting wrong with running experiments. Okay, so first, why experiment? Well, if you remember Lenny's talk from this morning, he said the newsletter started just as an experiment. He just wanted to try something out. And he figured out, hey, this is working. He got the right signal. That's what experimentation allows us to do. It allows us to find what is making impact and do so scientifically. It takes away this idea of hippos, highest paid person's opinion, and instead gives the power to us who believe that we can make impact with our ideas. And the fastest growing companies all have this belief. You know, whether it's an Airbnb, an Uber, LinkedIn, or a company like Descript or Perplexity. We are in this time of change in our industry where we have to do more with less. And that makes experimentation even more important. It tells us how we can, with less resources, keep learning and learn rapidly. If we can experiment as fast as possible, we can learn as fast as possible and really execute. And it's not just a process. It's not just what tool you use. It's a culture of experimentation. Because of experimentation and experiments that I ran, I was promoted, I showed impact, and was rewarded for it. And when we think of the customers that we work with, we look at who gets promoted within their companies for the impact that they're making. And that's what true experimentation culture means. So as I go through here today and tell you what we can do better about experimentation, we're going to talk about A/B testing, yes, but we're going to talk about more than that. We're also going to talk about experimentation culture. So today, we're going to go through why we're not using rigorous science when we test. We're going to talk about why we're not running enough experiments, why we're not making big enough changes, and because I have the pleasure of being on the stage, I'm going to do one more thing. All right, so issue one, we're not using rigorous science. So imagine you're in a meeting with leadership where a colleague says, I don't think those numbers are right. I have been in that situation. And what it did was throw out all the results that I had made. I was defenseless. It created weeks of work diving into our numbers to figure out what was right and what was wrong. And it did a lot of damage to the trust in our experimentation program. If we cut corners on the science, we leave ourselves vulnerable to this position. We dig ourselves into a hole where results can't be trusted. And it's hard to earn back that trust once it's lost. And that's why having rigorous science is so important, so we can have that trust. So what do we need to do to get this? Well, we need to go from an old world into a new world. So the first is that we need to go from siloed data that are in specialized tools into trustworthy data that's built on a single source of truth. That means that when you're looking at your experiment data, it matches what is in your BI tool that your CEO is looking at. And you can compare those numbers one to one so that when you look at a conversion rate number, it makes sense, or your revenue number, it all makes sense and it all connects. We need to go from a world where we go from imbalanced traffic discovered late and we're wasting time to balanced traffic discovered early, and we're going to dive more into this. And lastly, we need to go from drawing wrong conclusions from early results into making conclusions from powered experiments, and I'm going to explain what that means. All right, so traffic imbalances. you're running an experiment 50-50. That means 50% of traffic to A, 50% of traffic to B. But sometimes you see this. We're expecting 50-50, but you get 70-30. What's the problem? Well, good if we can detect it, but sometimes we detect it at the end of the experiment. You ran an experiment 4 to 6 weeks, and now your results are completely invalid when you have a traffic imbalance. That's 4 to 6 weeks wasted. That's 4 to 6 weeks without a learning. And so it's not just understanding that this makes our results invalid, but that we have to detect it early. And there are tools out there that we can have to monitor those assignments, that traffic, to make sure that we're catching this without wasting any time. Let me show you how this throws results off. MSN ran a test on their image carousel. They're trying to optimize for user engagement. On A, you have 12 slides in this carousel, and B, you have 16 slides. All right, who thinks A is going to result in more engagement? Okay, and who thinks B is going to result in more engagement? Kind of see equal around the room from what I can see through the fog. Well, MSN ran this experiment, and A was the winner. A was more engaging. But when I think about it, just kind of like going on a social network, the more content I have to scroll through, I would think maybe, that would keep me on site longer and engage me longer. And this is what the people at MSN thought. And so what they did was they looked at the data. And what they found was that the users exposed to version B engaged with it enough that they were screened out as if they were bots for suspicious activity because they were so engaged with it. And so what they did was they added that traffic back in. They got that balance of traffic right back to 50-50, and B was the winner. So that's how a traffic imbalance can completely throw off your results, completely the wrong direction. Let's talk about another problem I see. This is me. It's probably many people in this room. F5 is the refresh button. You launch an experiment, and you are just clicking. And I do this. I have that anxiety. And there's a problem with this. It's called the peaking problem, which is when you run a simple experiment, a simple test, it assumes no one is going to look at the results until that end date. So if you're peaking and doing that, you're actually doing the wrong thing, and you might see results that are incorrect. So as an industry, experimentation industry, we popularize another method called the sequential method, which allows us to peak as much as we want. Great. My anxiety feels so much better. But there's still another problem with this. So you see this, and wow, that's an incredible lift, right? 337%. And so, your IC goes, and it tells the CEO, wow, we just launched this experiment, and look at what the result is. Wrong. What's the problem? We don't have enough sample here. This experiment isn't what we call powered. It means that we don't have enough traffic to detect whether there's an increase of that size. And so we have to be careful with understanding what types of experiments that we're running and behave accordingly. So it's not that we need to curb behavior. It's just that we have to have this knowledge and know. And part of that is using a sample size calculator to understand what kind of change we can detect based on how long the experiment is running. All right, so understand the methodology and peak accordingly. Issue 2, we're not running enough experiments. Why? Well, if you think about what Jeff Bezos is saying here, we have to maximize the number of experiments you can do. The key really is bringing down the cost of experiments. Let's look at the research. When Microsoft looks at this, 33% success rate over all the experiments they ran. Booking.com, Google Ads, Netflix, best-in-class experimentation companies. 10% of the time they won. I don't know about you, but to me, that is drastically lower than the priors that I had. 1 in 3, or even 1 in 10%, 1 in 10 experiments win. So we have to know this, which changes how many experiments we have to run. But we also have to tell our stakeholders and set those expectations. If we have an experimentation program, it's important we understand that the key thing we're going to get out of experiments is learning, not necessarily winning all the time, because most experiments are going to be failures. We can forecast the number of experiments we need to run. It's just math. So let's say I have an impact goal for my area of the product. Let's call it 5%. Historically, I look at my success rate, 29%, average effect size, 2.5%, and then we have to take a haircut, a shrinkage number. Experiments just don't add together. They have interaction effects. I wish they did. I'd have made a lot more impact in my career. But if you have 2.5 and 2.5 on experiments, they don't add up to 5. The arithmetic doesn't work that way. But when you look at this math, I have to run 14 experiments to make this impact, right? 14. And so you can do this, look at your past data, and understand how many experiments do you really need to run, because it might be more than you think you do. So we need to maximize this run rate. How do we do that? Well, you look at what Booking.com did. What they focused on was allowing non-experts to run experiments. Experimentation is highly multiplayer. And it starts from leadership set with objectives, which is some of us in this room, and then pushing that down through maybe an experimentation platform team, product and design, engineering, and data science. And what I've found, what we've found at Eppo, is that data science tends to be the bottleneck, where if we can get them out of needing to be involved in everything, we can have the highest impact in increasing the velocity of experiments. And that's because they're involved in the input and the output of the experiment. Okay? So you go from a place where somebody can put in whatever metrics they want, and you have to collaborate with data science to figure out what are those experiments. We have to go back and forth. We have to have the meeting. We instead want to create a place where we have repeatable defaults, and these things are automated. We take a lot of the thinking out of it. So if you're running a search UX experiment, well, we know what the primary metric is going to be that we care about there. We know how long we should run those experiments. We know how we should roll out those experiments after they've concluded. These are things we can set, and we should make as repeatable defaults in our experiment. And beyond the inputs, it's the outputs, right? Self-service analytic tools. I can't tell you the number of times I concluded an experiment, and then I had to wait for data science to tell me what actually happened. And it wasn't their fault. They had other things on their plate. They have tons of tasks pulling at their time. I even had other things for them to do. But we can get them out of the loop. If we have self-service analytic tools, then a PM, you, me, our teams can do that, and they can analyze the data, and we can make decisions and move on. This increases our velocity and maximizes our learning. All right, issue 3. We're not experimenting with big enough changes, okay? We talked about maximizing the number of experiments, and I am not going to dissuade you from testing all the things. The truth is we do. We need to be testing all the things. If we have a well-founded hypothesis grounded in qual and quant data, we should be testing it, whether we think it's big or small. But we likely don't have time because we don't have the sample size to detect small changes. It takes 4 times longer to detect an effort twice as small. We have time constraints. We have to do more with less. And our experiments don't succeed most of the time. So we have to take big swings. So when we think about our experimentation culture, how do we get the organization comfortable with taking that amount of risk and taking big swings? Well, it's about putting guardrails on our program, whatever we're testing. So that means that you can put a downside that you don't want to be harmed. So maybe you don't want to increase the number of support tickets, and you have a threshold that you can detect. Maybe you can't decrease your total purchase count. In fact, I have worked with teams where they have a budget, where they know how much like revenue or conversion can be harmed. and they make sure that they adhere to that budget. That's what guardrails help us to do. That allows us to take risks and make sure that if we've seen this downside, we can pull the ripcord on that early. Another way where we think about taking big swings is finding where in our product is sensitive. This is a quote from Martin Tingley at Netflix. Once we know a product area is sensitive, we can move metrics there. We test as rapidly and as much as possible. And to do this, we need to keep a log of what happens, right? You need to understand and record what happened in your experiments and review it. Where did we find big impacts? Are there patterns in the areas? Products just happen to be persuadable in some places and tough to move in others. And so this can be in your tool, this can be in a spreadsheet, this can be in Coda. Coda, where's my money for that? Okay. We have to be logging what we're doing in our experiments to maximize our rate of learning. And lastly, look, a lot of this has been about A/B tests. But experimentation isn't just A/B tests. Lots of part of the organization experiments. In particular, marketing is also expected to run a lot of experiments. Growth is also expected to run a lot of experiments. So it's not just where the product is sensitive, it's where we're spending the money. Marketing incrementality is the connection of marketing programs to business outcomes. It's a way where we can test our marketing efforts as well. And usually, particularly in paid ads, is where we're investing a lot of our money. And if we can understand the causal connection between how we're spending money to those outcomes, we can make a high ROI for our business. And so you have tests like GeoLift, which we offer at Eppo, which can detect these things as well. All right, so in conclusion, we're now going to use rigorous science because we're checking our assignment balance, we're checking it early, and we're ensuring that our experiments are powered. We're running enough experiments because we understand our success and failure rate. We're doing that by creating repeatable defaults and setting up our team with self-service tools. And we're experimenting with big enough changes. We're utilizing guardrails to get everybody comfortable with downside risk. We're testing in areas that are sensitive, and we're testing where we're spending money. But I promise you one more thing. And what I'm going to do here is share some learnings about where I have found experiments being successful that you can take home with you. And there's a couple of themes here. One is education. My last job was at Cameo. And you know what? Maybe us in the room know what Cameo is, but a lot of people don't. And that was our number one thing. People didn't really understand what Cameo was. And there wasn't enough education we could put in the product to tell them that. Every time we did, we saw success. Here's an example from Blinkist that does something similar. They have a trial, and so they went from A, where there's some gray helper text, hard to read, to B, where it's very clear what's going to happen in this trial. Very clear, hard to mistake what you're going to get. And in fact, what I love the most is how can I cancel in gray at the bottom. That reassurance, right? Exactly what is going to happen. Education is a key theme to push on. 2 is trust. And I can't believe this, but I was in charge of checkout, and what I did was I added a lock icon here to this button. I did a little bit more. I added some credit card logos. I upped the language about security. But trust really made a 5% difference in conversion to checkout. And I've checked this story with other people who have run similar experiments, and it's true. Adding trust, especially on these places of value exchange, is really important. And so, particularly if you have areas like this, you should invest in experimenting with trust. And lastly, friction removal. I'm sure we all know this. We heard about simplifying our products. Simplifying usually works, right? So where can we take out a step in our experiment? Here's Hotel Tonight, removing a step from their reservation flow that required a sign up. And by doing that, they had a positive impact on their conversion to reservation. So I hope you can take that home with you. I hope we can experiment like the best now. And thank you very much for your time.